ZK Sync, Starknet, Linea, Scroll, Aztec. There's so many names, it's hard to keep track of them all. These are just some of the examples of the ZK rollups out there that are working to try to scale Ethereum. But this naming is actually very confusing for the general audience. If you're watching this video and you don't already know what I'm about to say based on the title of the video, this is going to be helpful for you. A valid ZK proof has three properties that make it a ZK proof. There's the property of completeness, which says that an honest verifier who's looking at that proof will indisputably be convinced about the thing the proof is trying to prove. Then the second property is soundness, which says that for a false statement, a valid proof could not have been generated, at least probabilistically. So therefore, having a valid ZK proof implies that the statement being proven must be true. And thirdly, there's the zero knowledge aspect of it all, which says that if the statement is true, the verifier doesn't learn anything about that statement other than the fact that it is true. We commonly see a couple of different types of ZK examples. If you've ever Googled or seen videos on YouTube about what even is zero knowledge, you've probably come across one of these two examples, Where's Waldo and the bartender example. So in the Where's Waldo example, let's say we have a really large image and Waldo is hidden somewhere. Somebody can provide a ZK proof that they know where Waldo is without pointing him out by basically covering up the entire image with like a black sheet and then making a tiny hole where Waldo is so you can see Waldo, the verifier can see Waldo, but you don't exactly know like how the image, how the frame is positioned behind the black sheet. So you don't exactly know like where Waldo is on that image. The second example that comes up a lot is the bartender example, especially in like identity related use cases, which says that, okay, you walk into a bar and you need to prove to the bartender you're over 18, but you don't want to tell them your exact date of birth. So you can do that with zero knowledge and ZK proofs. One of the things people often miss is both of these examples, there is an intention to hide information. You don't want the verifier to know where Waldo is, or you don't want the bartender to know your exact birth date. They intentionally want to hide information. People think with ZK rollups, because of the naming, they also want to hide some information. While technically this is true, it's not in the sense you might think. I've seen new devs, people who don't know much about ZK, asking questions like, oh, so it's on a ZK rollup, so it automatically must be private, right? All transactions must be private, everything must be private. I can store passwords in a smart contract and it's all private because it's all ZK. No, that's not how it works. That's not the point. In these ZK rollups, typically the snark or stark methods are used to create these ZK proofs. And both of these methods, snarks and starks, they have this really cool property called succinctness. What that basically means is the proof that they produce is usually much shorter and ideally a fixed constant size compared to the statement, compared to the data that they are trying to prove. That means you can have like a really large number of things you want to prove, but you can create a proof for it that's actually much shorter than the data you're trying to prove. In the case of these rollups, this specifically refers to transactions or batches of transactions. So what's the point of a rollup? Let's say we have 1,000 transactions and this blockchain, like every blockchain is like a state machine that is at like some state S, and then a transaction comes through, it executes it, and then it moves to some new state S1. If we have 1,000 transactions, then this keeps happening and we go from state S to S1 to S2 to S3, all the way up to like S1000. The goal of the rollup is to hide each individual state change, but rather batch up all these 1,000 transactions and give a proof to Ethereum mainnet saying we went from state S to S1000 without having the Ethereum mainnet recompute every single transaction. And the way that this works is it basically creates a ZK proof for each one of the transactions that occurs on the rollup, and then it sort of merges these proofs recursively until it ends up with like one ZK proof at the very end of it that effectively acts as the proof of all of those 1,000 transactions. And then this one proof is sent over to Ethereum mainnet, and mainnet can verify this one ZK proof and be convinced that all those 1,000 transactions must have happened and the state change from S to S1000 was valid. Now, for these rollups, it's really important that this proof is short and it's easy to verify, and the mainnet doesn't have to do a lot of computation because that computation is expensive, and that's exactly what we're trying to avoid with these rollups. But the point to note over here is they're not trying to intentionally like hide information. In fact, that would be a very bad idea if this data wasn't available for interested parties to verify one by one manually. And that's the data availability problem, and that's a whole another topic. So they're not intentionally trying to hide data from mainnet per se when they're creating these ZK proofs. They simply want to use the property of succinctness to be able to prove a large amount of data, a large number of statements in one shot. So they simply use the succinctness property and the soundness property of ZK proofs to prove that these state changes are valid. So they're better classified as like validity rollups, since what they're doing is they're proving the validity of a certain set of transactions, but they're not really trying to hide anything. But the naming and just arbitrarily calling them ZK rollups or ZK EVMs or whatever isn't really helping anybody, because it gets confusing, and folks who don't have advanced knowledge in the field of ZK can very easily get confused, are very easily getting confused with what this term actually implies. So I think validity rollups should have been their name. I think Vitalik expressed his opinion that validity rollups is actually a better name as well. So I think people are catching on. I don't know if we're at the point where there will be an industry-wide shift in the marketing and the naming of these technologies, but the point of the video is ZK Rollups only use ZK cryptography for succinctness, not for hiding any information, not for saying that the entire rollup is all private and everything. That's not happening. Peace.